All right, so I had a request for a domain question with a logarithm. So find the domain for f of x is equal to the natural log of x plus 3. I have a checklist for domain questions. And the first thing I check for is there's something that could give me a 0 in the denominator. And there is no denominator in that thing, so I am not concerned about that. Second thing on my list, is there something that could give me a negative inside of a square root or a fourth root or a sixth root, any even power root? I do not have an even powered root, so I'm not worried about that. But the third thing on the list, is there anything that could give me a 0 or a negative inside of a logarithm? And so that's where we have this particular question. Natural log is a logarithm, and I'm not allowed to take the log of 0, and I'm not allowed to take the log of a negative number. So in order to account for that, I need to take this x plus 3, and it has to be just greater than 0. I can't set it equal to 0 because we can't take the log of 0. And it can't be negative by saying it has to be greater than 0. That's my way of saying that this inside part of the logarithm has to be positive. So if I go to solve that, this is just going to be that x is greater than -3 if I subtract that 3 from both sides. So if x is greater than -3, and you're not sure how to do that in interval notation, if you put -3 on the number line, greater than -3 means open circle on the -3. And then if I go towards this direction, this is toward the direction of 0, and this is toward the direction of like more negative numbers. So like this would be like -6, and this would be like 0 over here. If I want x to be greater than -3, I need to shade toward the direction of the 0. I like to sometimes make a number line because it helps me do the interval notation part so that my domain we always write from left to right. The first thing that is part of my domain starts at that -3, but we're not including the -3, so it's going to get parentheses. And then it goes all the way to positive infinity. So that's how I would account for it if it's that kind of problem there. How would this change if we had some additional pieces? So let's say that I wanted you to find the domain So I wrote, find the domain for f of x is equal to the square root of x divided by the natural log of x plus 3. So we already took care of the natural log of x plus 3 in the last problem, but there's now a square root in there. And when I go through my domain questions, I don't have a denominator that could equal 0 because I already accounted for making sure that's not equal to 0. So I'm okay there. I already took care of the logarithm part, which is number 3 on the list, but I also have a square root in there. So all 3 of the things are things that we have to be careful of for this one, because there is a denominator, there is a logarithm, and there is a square root. What's my rule for the square roots? Am I allowed to have x equal 0? Can you take the square root of 0? Square root of 0 is just 0. So square root of 0 is okay. So this first part, the square root of x, I just need x to be greater than or equal to 0 for that part. That's the numerator part. So the numerator says x has to be greater than or equal to 0. But my denominator is the same thing that we just did. And my denominator said that x has to be greater than -3 when we solved it. So in order to answer this question, I have to account for both of those things. And so this is, again, where a number line is a really good idea. So I'm going to put down -3. And I'm also going to put down 0. And so same thing when we talked about in the last one, it's not allowed to actually be -3. But it is allowed to be 0. I have the or equal to sign on the 0. So I'm going to go ahead and put a closed circle on the 0 part. Okay. So what this says is that I need x to be greater than or equal to 0 to satisfy the condition for the numerator. And I need x to be greater than -3 to satisfy the condition for the denominator. Both of the conditions have to be satisfied. So what's my answer have to be? Got an idea?
The bottom range of the domain is -3, not included. So, because of the logarithm.
Because of the logarithm. But the numerator says I'm not allowed to put anything in there that's smaller than 0. 0 is okay.
Oh,
Both conditions have to be satisfied.
I know.
Both have to be satisfied. So what's my answer? So it's 0 all the way to infinity are going to be the answers that are okay for my answer region. So even though we needed to account for the logarithm part, the numerator part, because it's in order to satisfy the numerator, x has to be greater than or equal to 0. That starts here. All this stuff over here doesn't matter anymore, because in order to take care of this condition, it has to be everything from here on over. So I'm not even going to care about the -3 part anymore. I have to start at 0, but 0 is actually okay. So it's going to get square brackets and it's going to go up to infinity. So when you do domain questions, if the thing has a square root and it also has a denominator and it also has a logarithm, you have to make sure all 3 of the conditions are taken care of. So we have to account for all of the things to make sure that we're not including any of the stuff that would give us a problem. So that can be a little bit tricky when you're doing domain questions. So that's where I'll put a number line in there to kind of be like, what is actually getting included here? So before we could include everything from here on over. That was our answer to the first part. But because of the numerator in our second question, I actually have to exclude all of that part and I can't start till I hit 0. Questions on that? That one's a little tricky. And let's switch to average rate of change. So it's a crazy looking graph. It says, what is the average rate of change over the interval from x is equal to -8 to x is equal to -2? When you talked about average rate of change today, what are some things that came up? What's in your head when you see this? What are you thinking you need to do? Tangent line. That's a word that came up today. What other words came up today? Secant line. That's another word that came up today. You talked about an average rate of change. And then did you also talk about an instantaneous rate of change? And did you talk about the difference between those two things? Theoretically, right? And that's the part that's the tricky part of this lesson. Okay. So average rate of change is just a fancy way of me asking you, can you find me the slope of the line between the 2 points they're talking about on this graph? And how do I know what points they're talking about on this graph? Well, for one, I actually put points on this graph, so I made it a little bit easier. But let's pretend there were no actual points on the graph. It says, what's the average rate of change over the interval from x is equal to -8? This is my x-axis. And so -8 is right here. And so I want to go down to where that's actually hitting on my graph. And that hits right here at the point -8, comma, -8. So we have a point at -8, comma, -8. There's a point. And then where x is equal to -2, this is x is equal to -2. Where is that hitting on my graph? That's hitting at +3. So -2, comma, +3 is another point on this graph. And you got a formula today for average rate of change where it said you were going to take the f of the second thing minus the f of the first thing and then divide it by the difference between the two things.
I think you can also say that the f is equal to a y value.
It's literally find me the slope is another way I could say this. If I give you 2 points and I said find me the slope, would you be scared of me asking you that? Your slope is y2 minus y1 over x2 minus x1. That is actually the average rate of change formula. If we write it with f's, it doesn't change anything. So let me write off to the side here. M, which is slope, is y2 minus y1 over x2 minus x1. That's how we talked about it in algebra. Okay, but I could have also written this as f of x2 minus f of x1 over x2 minus x1. That formula looks a lot scarier because it's got additional stuff in it. But remember when I've written things like an equation, so I could say y is equal to x squared plus 3x plus 1, but I could also write f of x is equal to x squared plus 3x plus 1, and I mean exactly the same thing. So we've had like worlds where we've already had conversations where we've said, oh, f of x just means y, right? So all I'm doing over here is I'm changing the y into an f of x thing. And the f of x, because I was talking about x2 the first time, then the y that goes with it is f of x2. And because I was talking about x1 the second time, the y that goes with it is f of x1. It's the same formula. It's exactly the same formula. But now it looks like the one that we're using in calculus. So you're really just finding me the slope between those 2 points, which I know you know how to do. So we just have to choose which thing we want to call our x1 and our y1 and which thing we want to call our x2 and our y2. So I'll go ahead and call this one my x1, y1, or my x1 comma f of x1. That's another way I could have labeled this one. So, oops, I should have done x sub 1 comma f of x sub 1. Exactly the same. And then this one would be my x2 comma y2, or another way I could have labeled it was x2 comma f of x2. They mean the same thing. So plugging that in to our formula, I'm going to take 3 minus -8 and divide it by -2 minus -8. So 3 minus a -8, that's going to be an 11. And -2 minus a -8 is going to be a -2 plus 8. So that's just 6. So the answer to the question, what is the average rate of change over that interval, is 11/6. Another way I could have said that is find me the slope of the line between those 2 points. So average rate of change is us talking about a line drawn between 2 points. And if I drew the line between those 2 points, I'll draw a terrible line between those 2 points probably, but a line between any 2 points that we've selected is called a secant line. So if I give you a graph and I put 2 points on the graph and I ask you to find me the slope of the line between the graph, that's just you doing algebra. You've been good at that for a good long time. The question becomes calculus when I ask you, what's the slope of a line that I could draw that just only touches right at that point right there? And so you would have to draw what we call a tangent line. A tangent line only touches in 1 point. The secant line goes between 2 points on a graph. But if I only get to put 1 point on the graph and I say, hey, I want you to draw me a line that only touches this graph right at that point, that's called a tangent line. You know, and so maybe your tangent line is right there. And if I said, hey, what's the slope of that line?
Slope of a secant line?
Ooh. So slope of a secant line means I have 2 points. But if I ask you what's the slope of a line here, we have a problem. Because in algebra, if I ask you to give me the slope of a line, I have to give you at least 2 points so that you can do the y2 minus y1 over x2 minus x1, or our new formula that we use today. But if I just give you 1 point and I draw you a line that's touching on that point and I say, what's the slope of that line? You should go, because you need 2 points to give me the slope of a line. So this is why you're taking another class now, because in algebra, you could tell me the slope of a line if I gave you 2 points, but now you only get 1 point. And if you only get 1 point, you need a new tool. And that's calculus. And so the thing that you're finding, the slope of the tangent line, involves using the other formula you got today. That was your instantaneous rate of change. So if I'm asking you for an average rate of change, I'm asking you for the slope of a line between 2 points using our old formula from back in algebra. We sometimes write it looking a little scarier by putting the f of x's in there, but it's the same formula. But if I ask you for the instantaneous rate of change, I'm now asking you for something fancier. Now we're talking about calculus. Okay. Question?
So would this be like formula for velocity, distance divided by time, similar, or did I get the wrong sort of formula idea?
In this scenario, I didn't actually give you like units like time or that kind of deal, but differences where I could be asking you for the average velocity. If I ask you for the average velocity, you're just going to have 2 different points and you're going to do your y2 minus y1 over x2 minus x1. If I ask you for the instantaneous velocity, then we're now using a completely different formula. And that's the process that is going to be introducing a topic that's going to be something that we're really hitting hard on Monday called limits. And so this 2.1 section in your textbook is one that a lot of professors will skip over at first and they come back to it later, because kind of to understand this section, you have to understand some stuff we're going to talk about on Monday, which is a little weird. So we're sort of doing it in a little bit of a roundabout way, but we'll get there. Don't freak out too much. We'll get there. So I did not answer the question, what is the slope of the line there? I'll come back to this answer in a second. When I ask you, what is the average rate of change over the defined intervals? Versus when I ask you, what's the average rate of change on a graph? And I say, from some x value to another x value? I've actually asked you the same question, okay? So I can give you different representations of exactly the same question. So the next question that I'm giving you is exactly what we just did, okay? But you didn't get the picture this time. So how would we do this problem if you don't get a picture? Here's how we would do this problem. Let's do part A first. The interval they're giving you, that's an x, and that is also an x, okay? To answer this question, because I said it's exactly like the question we already did, we also needed y's, didn't we? How do I get y's if these are my x values? The 2 and the 3 are my x values. Indeed, you put those two values into the function. So the 2, if I wrote it as a point, this is 2 comma something. The something that I'm going to get is what I get if I plug it into this function. So it's 2 comma f of 2. So you're going to come to your f function, you're going to put a 2 in there. Is that okay? If you plug in 2 into your f function, f of 2 is equal to 2 cubed plus 1, which is going to be 8 plus 1 or 9. So this point 2 comma f of 2 is the point 2 comma 9. There's our first one. And so I can call this one x1, y1. That's my first point. And then my second point needs to be using the 3 comma f of 3. So f of 3 is just 3 cubed plus 1 more. So 27 plus 1 more, 28. So I have the point 3 comma 28 as my second point. So I'm going to call that x2, y2. And so I asked you for the average rate of change between these 2 points is really what I asked you. So now you're just going to go find me the slope. You've done that bunches of times. So that's the same thing as y2 minus y1 over x2 minus x1. So 28 minus 9 over 3 minus 2. Which is just 19. So that's our answer to part A. So I'm gonna have you take a second. Try part B, see if you've got this. So for part B, you're doing exactly the same thing, but the x values you get this time are -1 and +1. So see if you can match up what we just did. You're using -1 and +1 as your x values now. Did you get the points -1, 0 and 1, 2? And once you've got those, you're just finding me the slope of the line between those 2 points. Sure. Did you get 1? That's your answer? Nicely done. Okay. I can't actually see your homework questions because I can't get into my lab thing, but do you have problems that are already posted that are on this stuff yet? Or is it all the stuff, the review questions so far?
Well, it's posted, but it's not really graded.
Got it.
So
He says you got 2 weeks to do it, so it's not like anything. I just was curious if anyone's already jumped in and started doing stuff. It's okay. So what we're starting with is things you've seen. You've seen slope. They're just saying the words in a way that seems a little bit scarier. The one that's sort of new is us finding an instantaneous rate of change. Another way of finding an instantaneous rate of change is you finding me the tangent line to the curve at a point. So that is me answering the next question where I was like, you only get 1 point now. How do we find the tangent line there? So you're finding a slope, just like we just found slopes, but we have to be clever about it because we only got 1 point. We didn't get 2 points. So here's our scenario. What is the slope of the line to the curve at just 1 point? And then we're going to use that slope to actually write the equation of the tangent line actually at that point. So here's the curve where I'm not going to draw you the curve, but it's a parabola. You could totally sketch this parabola, right? This is just x squared, the parent function, and then moving it down 5 units. But it's saying if you drew that parabola and you found the point 2, -1, which is on that parabola, could you find the slope of the tangent line that hits right at that point on the parabola? And yes, you can, but the technique is a little weird. So we're going to be using the other formula to do that. Okay. How many people just had Dr. Burke last quarter? Do you remember talking about difference quotient?
Difference quotient?
Difference quotient? I don't know, maybe it had a different name, but you would have had an f of x plus h minus an f of x divided by an h. And then she may or may not have talked about taking a limit eventually as a thing that would come up in calculus.
No,
Maybe not.
no,
Didn't do that?
I don't remember this.
All right. Well, folks who had me last quarter, we did that. So I was curious. Maybe not. All right. Then I'll use different language. Don't be scared. What we're going to do is we're imagining a scenario where we're going to pick another point that's super close to that point.
Oh, we went over
It's
this.
h units away. And when I say h units, literally h could be anything. It could be 100 units away. It could be half a unit away. It could be a quarter of a unit away. It could be 100th of a unit away. It could be 1,000,000th of a unit away. We can make it smaller and smaller and smaller. And in calculus, we eventually want to make it equal to 0, kind of, sort of, except that we can't divide by 0. So we do this thing where we pretend we're dividing by 0 by talking about getting as close as possible, but never actually getting to the 0 by making the number smaller and smaller and smaller and smaller and smaller. You don't have to worry about that part right at the moment. That'll be our Monday lesson. But for now, could you believe that there'd be some other point Q that's really, really, really close to this point that's at 2 comma something, but it's going to be h units away from that 2. So I'm going to say 2 plus h. That h is so random because it could be a really big number or it could be a tiny number so small it's practically 0. Okay. And now I don't want you to freak out about the next one. I'm not going to put -1 plus h. What we're going to do is we're going to use that notation where I'm taking the thing that I'm plugging in and we're calling it f of some other thing. So what I'm going to write is this, the thing that would be popping out. So pretend this said f of x was equal to x squared minus 5. And I wanted you to write the f of this thing. Could you do it? What would be f of 2 plus h? Do you see how that's f of 2 plus h? F of 2 plus h means where I see the x right here, I have to put 2 plus h in there. And then we're supposed to square it and then subtract 5 from it. So what I've just written is they gave us a point 2 comma -1, and I'm choosing another random point that's as close as I want to be to this point right here. And I can make it super, super far away if I make that h a really big number. Or if I make that h a really small number that's 0, what if I made that h 0? If I make h 0, this becomes just 2 again. And if I make this h 0, this becomes 2 squared, which is 4. And 4 minus 5 is -1. See how it becomes exactly the same point again? So this is our way that we write a point that's as close as we want to be to this point based on however big we choose to make that h. If we make that h a really big number, this point is hella far away. If we make that h 0, it's exactly the same point and they're sitting right on top of each other. Okay. So I've now given you 2 points, but really I only gave you 1 point. I gave you 1 point, but we made a second point that could literally be the same point if we make the h equal 0, right? So you're going to use now your same y2 minus y1 over x2 minus x1. This is your instantaneous rate of change formula. So if I want the slope, this is going to be my x1, y1, and this is going to be my x2, y2. It's just my y2 is kind of funky, but it's okay. We're still going to use it the same way. So I'm going to write my y2 is 2 plus h squared minus 5. That's my y2. Then I'm supposed to subtract y1, which is a -1. So it's subtract a -1 over my x2, 2 plus h, minus my x1 is 2. Okay. We are going to simplify, and here is where you get to impress me with what you remember. 2 plus h squared is not 4 plus h squared. That's the most common mistake. Remember, 2 plus h squared means 2 plus h times another 2 plus h. So you got to FOIL that or box method that for me. So that's going to be 4 plus 2h plus another 2h would be 4h plus h squared. If you can't do that in your head, that is a-okay. You can totally FOIL that off to the side or box method that off to the side. So I just did 2 plus h times another 2 plus h minus 5. And then minus the -1 will be a +1. And then in the bottom, we just have h now. Cool. I'm going to just add up the constants now. So 4 minus 5 would be -1, plus 1 would be 0. So those got wiped out. So I have 4h plus h squared.
And then you can factor out h.
All right. And yeah, now we're in a scenario where both of the things in the top have an h. So we're going to factor the h out. And now that I've factored one h out, I can go ahead and cancel that h from the top and bottom. So I'm dividing h divided by h.
Would it be easier just to like cancel out the exponent as well as the bottom?
Cancel out the exponent. So here you would cancel out the h entirely, and here you would take the 2 and subtract the 1.
Yeah.
Yeah, if that works for you. I do better when I factor it out, but if that works better for your brain, it's totally fine to do it that way. So what we ended up with here is 4 plus h. If Dr. Burke had talked about difference quotient, she would talk about this concept of once we get here in the land of limits, which we'll talk about on Monday, we let that h go to 0. And if that h goes to 0 or becomes 0, then our answer comes out to be 4. The slope of the line that's between these 2 points, as we move them closer and closer and closer together to where they're practically the exact same point, the slope is just 4. So that h goes to 0. So we write that with a little arrow pointing to 0. H goes to 0. Means that 4 is the slope of the line to the curve at that point. Does this look anything like what you did with Dr. Littman today? Was he just drawing you a bunch of things and putting the lines closer and closer together? It's usually how they introduce it. And then these are the math problems they give you for homework usually. So let me read the question again. What is the slope of the line to the curve at the given point? We just took care of that. The slope is 4. And what is the equation of the tangent line to the curve at that point? All right, that's the part we haven't answered yet. It wants the equation of the line, and the slope is what we just found. Okay, so they want the equation of the tangent line to the curve at the point they gave us. So we have a slope and we have the point 2, -1. If you have a slope and you have a point, can you write the equation of the line? So the answer should be yes in a perfect world. But if your answer is, Jen, I now have no idea what to do, this is where you want to pay attention because it's important to be able to find the equation of a line at this point. So this is the slope. I'm going to say that's equal to m. Slope in my line equation is always the m. This one they just gave us is an x value. And then this thing they just gave us is a y value. And there's a few different ways you can do this. Some of you would have learned point slope form to do this. Point slope form for the equation of a line is y minus y sub 1 is equal to m times x minus x sub 1. That's called point slope form. Or there's just the normal slope-intercept form, y equals m x plus b. You can use either of these to get the answer. If you're using point slope form, then what you're going to do is you're going to use this 2 as your x sub 1, and this y, or this -1 is your y sub 1, and then our m is going to be the 4. We're going to plug that in so that you have y minus the y sub 1 is -1 is equal to m is 4 times x minus, and the x sub 1 would be the 2. So you would say that that is y plus 1 is equal to 4x minus 8. And then you'd almost be done to write that in slope-intercept form. You would just subtract that 1 from both sides. So we'd have y is equal to 4x and then subtract 1 from both sides minus 9. That's one way to do it. Another way to do it is you start with the y equals mx plus b, because some people never remember the point slope form. They're like, Jen, it just doesn't stay in my head, but they always remember y equals mx plus b because they're like, that's just the equation of the line. I remember that one. Cool. Then what you do is you take this as your y value. So -1 is my y. You take the 4 for your m. You take this as your x value. So I'm going to plug in the 2. And then the thing you don't have then is the b, and you go find the b. So if I do it that way, I have -1 is equal to 8 plus b, and then you'll subtract the 8 from both sides. And that'll give you that your b is equal to -9, which matches up with our b here as our -9. So then you would just write your equation of the line y equals, you'll plug the slope in, which is 4, and you'll plug your b in, which is -9. And you'll get exactly the same answer that we just got. Y is equal to 4x minus 9. So either way is totally valid for getting your equation of the line. Okay. So basically what you did today is you reminded yourself how to find the slope of a line between 2 points. That's called finding the slope of the secant line. If you want to find the slope of the line at just 1 point, we do this instantaneous rate of change, which involves us doing this trick where we took the point they gave us and we made it look like we had 2 points by adding this h on. And then instead of writing -1 plus h, we take the 2 and we plug it into the function. And so you'll take f of the x value that you had, and you'll put that down for your y value. And that lets you do the trick where the h could be really huge and then they're really far apart, or the h could literally be 0 and then they're actually the exact same point. And so in calculus, we do a trick where we let the h go to 0, and that gave us the slope for the right at that particular point. And so it's a trick you could never do before. You were never able to find the slope at just a single point, but you can now. So congratulations, you've made it to the land of calculus. You have a new trick in your toolkit. Okay. What you're going to do Monday, did you hear you're going to have a guest lecture on Monday? All right. So if you had Dr. Burke, you already know who your guest lecturer is. Dr. Burke is your guest lecturer on Monday. If you've never had Dr. Burke, she's a very good instructor. She's going to be talking about actual limits and how we take limits by looking at graphs, or how we take limits graphically. And so in those scenarios, you are talking about looking at something as you're coming from the left and looking at something as you're coming from the right. So if I had one piece of advice for this weekend, it would be to practice remembering where left and right are, because that's going to come up a whole lot on Monday, and I'm very bad at it. So sometimes writing right and left. I learned the trick, what this is left, if it actually makes the L in the correct direction. Because you're going to be talking a lot about something called left-hand limits and right-hand limits. And so you'll be coming from the left, coming from the right, and talking about what does it look like your graph is doing at those places. So I can show you one quick example and then I'll set you free. So this is a crazy looking graph. It has one piece right here, and that's the equation of that piece. And then it has this other piece right here, and that's the equation of that piece. Okay. And sorry, that's the equation of the other piece. We have an open circle happening here. And when you're talking about coming from the left, you're coming from this side. What's the first graph that you hit? Are you hitting the thing that looks like the cubic function? Or are you hitting the thing that looks like our 1/x graph, if you're coming from the left? The one that looks like the cubic function, right? And if you're coming from the right-hand side, the one that you're hitting is the one that looks like 1/x. And so when we're doing limit problems on Monday, we're always going to be coming from off the page and talking about what's the first graph that you hit and you're coming from the left. And we'll be talking about what does it look like that graph is going to do. And then if they say coming from the right, literally it's like you're off the page. What's the first graph that you hit when you're coming from the right? And then we talk about what does it look like that graph's going to do. So she's going to be showing you pictures of things and you're going to be talking about from one direction or from another direction, what does it look like the graph is going to do? Okay, so it's not as scary as it sounds. The words all come out like something crazy is going to happen. But for the most part, you're going to be looking at pictures and then you're going to be plugging in numbers into equations, which you're really good at. So the limit stuff starts off looking like it's scary, but I promise it's not as bad as it sounds. All right, I'll set you free. It's Friday. Have a good weekend. Catch up on sleep.